Okay, so we have a linked list programming question. Write a method remove duplicates. So our method name is remove duplicates. If you have noticed, it doesn't say write a static method. So it means it's not a static method. It's just a method because this method will go in your linked int list class, which you have created previously. So there is no concept of static because this is static methods are part of the class where you are writing your main methods, right? And they're associated with the class. They're not associated with the objects of linked list. So these remove duplicates will be associated, it will be associated with the objects of your linked int list class, which you have created previously. Okay, so this is not a static method. Write a method remove duplicate is your method name that could be added to the linked int list class from lecture section. The method should remove any duplicates from the linked list of integers. So we have to remove all the duplicates. If you see any duplicates, you have done this with arrays, simple arrays in Java 1. You have seen removing duplicates with simple for loops with your variables. You have seen remove duplicates in your array list and stack and queues. So there you have done in every collection framework of Java, removing the duplicate. So the task remains the same. But now when it comes to the linked list, we have seen how linked list stores the data with node by node, and every node have an address and the data value. So if you are removing 14, you cannot just simply say, hey, remove 14, because if you remove that node, that 14 is holding the address for the next node, and next node is holding the address for the next and next and so on. And you, after, if you are not taking care of the address for the next node, it's like a train. So if you have lost this one cabin, you just lost the rest of the train. So if I remove, just simply remove 14, just like we were doing in array list or simple arrays, it will damage my rest of the list. There is no longer, there will be no longer the rest of the list. It will be gone with this 14. So when you have to remove something in linked list, it's very important to keep hold of that data. That's what we have done previously in our last lecture with list node as well, where we were doing list.next.next, making sure that the address or reassigning the addresses is also making a difference. So if I say 14.next you are equals to something else, then again you have lost some values which you may need in the future, right? So working with linked list, and especially with list nodes, individual list node, is very complicated, which you need to make sure. So let's take a look. After the call, what we are doing, simply, this is an example, this is your list, and after the call list.remove duplicates, this is your output, and what you have done is all the numbers appeared only once, so all the duplicates in that list are removed. Okay, so it's simple. You need a for loop. We usually do with arrays and array lists, where you run a for loop and check one node by one and then remove that part. But now with linked list, it's totally different. So let's take a picture of this question so that you have in front of you, because I will be switching. First time, let's try this whiteboard strategy we have with the Zoom. So let's see how that coding will work. I am not doing it on Eclipse. You can write the code in your linked int list class previously created, but I will be doing a dry run. Okay, so that we can see how the code works. So take a picture in front of you so that when I refer to those terms or any values, you have in front of you. They have read out the whole question. It's just, I have just summarized everything. Like we will be writing this method in our linked list class. It's like the previous lecture. You have list node. They have explained each and everything, that every node over here is holding a data value and the address, quite similar to what I just said in a summary. Okay, so done taking picture. Okay, now what I will do is let's start this whiteboard strategy, new whiteboard. Can you see the whiteboard? Use React. Okay, great. Okay, so first of all, we will write our text. Let's start writing our method. So there is no static method. So it means there is only just the method with public. So no static. Return type is void because it has not mentioned to return something. We are just working or rearranging the list with the by removing all the duplicates. Method name is remove duplicates, and open close parentheses, and starting curly braces and ending curly braces. Okay, so let me stretch that one out. Okay, public void remove duplicates. This is your method. Now, when it comes to removing some duplicates, what you need to make sure, as we are comparing how to remove duplicates, we'll start with taking the first value and comparing it with rest of our list, right? That's how we compare the duplicates. Like if there are any 10 in the rest of our list, if you see any list, then just remove it. But in linked list, it's very different. So let's first draw on this side a sample list. Oops. I'm just creating a sample list. 2, 3, 4. I think 4 will be fine. Let's do 5 at least. 5 values. Okay, so let's draw a line. Creating linked list. These are all your list nodes, right? And all of them are connected. This topic is very important because binary tree is a combination of linked list and recursion. So if you are having trouble understanding linked list, it will be very hard for you to understand binary trees. So now let's write the numbers. What do you think? What number we should go for? Let's write 5. Okay. Another text. 4. And five again. This is 4. Let's make a duplicate of 5. And rest of the values are no duplicates. 7. And we can later on, when we do a dry run, we will later on change the values so that we can see these lines represent, they are all holding the address for one another. Now let's do, this is our front, okay, as mentioned from our list. So what's the front? The first value, the first node is your front. Let's draw a line for front too, and front is pointing at 5. Okay, now when it comes to the duplicate part, okay, so whenever you are writing a programming question for linked list, first thing is, especially for our int list class, so we know front is the one who is holding the address for the rest of the list, right? If you remove front, the list is gone, right? So what we will do is we will create a list node, current list node current equals to front, because we cannot run a loop on our front. As mentioned previously, you cannot run a loop, because if you run the loop and you reach at the end, then the list is gone at that point. So always the first step for you in linked list programming is list node current equals to front, so that you can run your loop on current. So after this line, what just happened is that you have a variable current of list node. It's not an object, it's a variable current. Let's put current here, and then who is also pointing at your list. So now your list is secure, right? So now let's go back to our, oops. Okay, After doing list node current equals to front, so it means our current is pointing at our list as well. Our list node front is pointing at our list as well. Now you need to run the loop. What is our task? If you see a duplicate, remove the duplicate, right? So that's our simple task. Now we have to go through our list. With linked list, we will never use a for loop because we don't know how big the list is, right? So first thing is creating your current equals to front. Second thing is your while loop. While loop are always used with the linked list because they are so flexible, so effective, and so easy to use and make a condition with your linked list. While what? What do you think will be the condition? On which of these you will run your loop? On which of these variables you will run your loop? While what? While current. So you will always, and how long we have to go through the list? How long? Do we have to stop after 2 nodes, 3 nodes, 4 nodes? How long do we have to go? How far do we have to go in the list? Not null. So as long your while is not null, right? So a while, we have to say current is not null. As long your current is holding a value, which is current is not equals to null. So that's our first condition. And as you are checking the duplicates, right? Our task is, so when we are checking a duplicate, so how you will check a duplicate? So you will compare 5 and 4, right? Then you will compare 5 and 5. Then you will compare 5 and 7. Then you will compare 5 and 8, right? So inside of your code, it means you are doing a comparison of 2 nodes every time. It's not like you're working on single node. So your while loop will not be just current is not equals to null. Your while loop will be and operator. Do we have more nodes to compare, right? So and current dot next is also not equals to null. That do we have another value to compare? Yes, then go inside of your loop, right? Otherwise, there is no point of going inside of the loop. Now, while your current is not equals to null, which is not null, your current dot next is not equals to null, which is also not null. So now you go inside. So when you are inside, what is your next task? What is your next task? How you will compare and remove the duplicate? What is your next task? So if we are removing something, right? So if we are removing, so it means we need to secure the data as well because our front is not moving. Our current is the one who is going through our list. And what if we have one more 5 here? So we need one more variable who can hold the address. So if we remove this 5 is holding the address. So it means our another variable must be there to hold this address and reassign it to 4, the previous one, because we have to stay one step back. Remember this, whenever you are working with linked list, where with the removing part, you are staying one step back, because if you want to remove this 5, you have to stop at 4 so that you can remove 5. Otherwise, if you are at 5 and you are comparing 5, the data of that current address, there is no point of moving back there. This address is holding something and it will mess up your whole list. You have to remove this address from 4. Okay, so we need one more temporary variable. You can say you can give it a name as current2, or you can give it a name as temporary equals to a will be current for now. So when we see any, when we have to remove something, we can easily assign it to the current2. Now we have to run our loop to check whether we have duplicates or not. So our current2 dot next is not equals to null. This is going through our list. Let's go to our list, and what we are conditions are if our current2 dot next dot data. To compare the value, you have to say dot data equals to what? This is very important. Equals to what? Your current dot next dot data. So what is current dot next dot your current2? I have not created current2 over here. So current2 is also pointing at 5. Current2 dot next dot data, which is 4. So you are comparing 4 with what? As you can see, as I mentioned, with linked list, we have to stay one step back. So what you are doing is you are comparing the next value with the previous one, so that if this is a duplicate, you can stop right here and make a change. So current two, sorry, not current, the current two is dot next. Oops. This is current two. Current two dot next dot data equals to current dot data, because current dot data will not move, right? It's 5. Current dot data is 5, and current two dot next will go through our list and compare with current dot data. Okay, so if this is true, if current two dot next dot data is equals to current dot data, then what? Then what? If that is equal, how to remove in linked list? If it's equal, then what? Let's say your current two is pointing at this 5 dot next dot data, and you are saying current dot data. Your current dot data is still at 5, so your current is not moving. As you can see, this while loop is just on the first one. When your 5 will be done, it will go to the outer loop, and then your current 2 will be updated with the new one. So current 2 dot next dot data equals to current dot data. If this is true, then what? Yes, current 2 dot next you will be equals to current 2 dot next you will be equals to current 2 dot next. Move to the next node. This is where your curly brace will close. This is where we have else is the case where they are not equal. They are not equal. So it means what you have to move. If they are not equal, it means that's fine. There is no duplicate. Then what? Who should be moving next? Otherwise, your while loop will be an infinite loop. You have to move someone. Who's going to move? Current 2. Yes, current 2 will move. Current 2, you will be equals to, it's like an increment operator, current 2 dot next, that move to the next node, closing curly braces. Else is the case, then this is where your F will close. This is where your inner while loop will close. Your list will close, and then you have the outer current equals to current dot next. So let's take a look how, and you have multiple curly braces, closing curly braces here. Okay, let's see. Okay, now let's do a dry run. Okay, let's take a look of this code and let's do a dry run. What we have. Okay, we have current 2 dot next who's pointing current 2. Let's put current 2 here, and we have a line. Your current 2 is pointing at this one. Okay, you have first node. So this is our list, and what is our task? We have to remove the duplicate from the list. And according to our list, as you can see, this 5 is a duplicate and rest of the list is the same. So let's see how this dry run will work. Public void remove duplicates. List node current equals to front. So our current is pointing at front. This is our front. This is mentioned in your question that the front of your list will be the first node. That's your front, and you never ever apply any loop on your directly on front, otherwise you will lose the list. So this has been discussed in our previous videos, why, and in detail explanation. So current is pointing at front. Then we have our while loop, the outer while loop. Draw color change. This is our outer while loop. So what our outer while loop is doing is current is not equals to null. So this is doing the major comparison with this current. So if your current is not null and your current dot next is not null, because our task is to do the comparison. If you don't have any other node to compare, what if you have only one node in the list? You have only 5, right? This is your list. Then if you don't have current dot next, so there is no point of running this code, right? There is only one, there is no duplicate. You can simply say there are no duplicates, or I'm done with the duplicates, right? So that's why we have to check and operator, current dot next is also not equals to null. So if your current dot next is not null, then go inside of this loop. So as we are moving inside of the loop, what we have is list node current to. We got another variable because this will be going through our list. This is one by one, and this will, okay, so this current will take the first node, and this current to will compare rest of the list with this current. And then this current will increment to 4, and then again current 2 will take 4 and compare it with the rest of the list, like this. So that's why we have current 2, which is equals to current, not equals to front, because current will update on every iteration, right? So front is same, front is always holding 5, but current will increment to 4, will go to 7, will go to 8, but that's why your current 2 will be updated to current. Now your current is first initially pointing at 5, your current 2 is also pointing at 5. You have again a while loop. This while loop starts and ends at else over here. So your while loop is current 2 is not dot next is not equals to null. Is your current 2 dot next is not null? True. Yes, it's not null. Then go inside and check if current 2 dot next dot data, which is current 2 dot next dot data, which is 4, is 4 equals to current dot data. What is current? Current dot data is 5. Is 4 equals to 5? Is this if condition true? No, we go in else. Else says current 2 increment, move on to the next node, current 2 you are equals to current 2 dot next. Current 2 is now incremented and current 2 dot next. This is current 2, right? Current 2 dot next is now 4. So your current 2 is pointing at 4. This is your current 2 now, and your current 2 is pointing at 4. Okay, I'm just making the name on top of that node. So current 2 is now pointing at 4. Now your inner loop, this is a nested loop, remember, right? So as long this current 2 is not false, you will not go to this outer loop. So we are still working on this orange loop. So current while current 2 dot next is not equals to null, current 2 is this one, dot next is not null. So we go again inside if current 2 dot next dot data, current 2 is this, current 2 dot next dot data, which is 5. Let me 5. Current 2 dot next dot data is 5. Is 5 equals to current dot data? So current dot data, current is still purple one pointing over here. Current dot data is 5 is equals to 5, which is true. So your if condition is true. So if this is true, now what you said current dot next, which is current dot next is this one. Current dot next you are equals to current current 2 dot next, current 2 dot next you are equals to current 2 dot next dot next. So point on this one. So you have removed this 5. Current 2 dot next dot next. So this is your current 2. This is current 2. You have pointing, you said current 2 dot next. This is dot next, point to dot next and dot next. Now this address is removed. Your current 4 is pointing at 7. Again, orange loop where you said while current 2 dot next is not null. Current 2 is still here. Is current 2 dot next is not null? Yeah, it's not null. It's holding 7 now. So is current 2 dot next is not null? No, it's not null. You go inside, you are checking if current 2 dot next dot data. This is your current 2 dot next. This is your dot next, right? Dot data, which is 7. So dot data 7 equals to current dot data. What is your current? Your current is still here. Current dot data is 5. Is 7 equals to 5? Your if condition is false. No, 7 is not equals to 5. You said, okay, move the current to the next node. Current 2 you are equals to current 2 dot next. So this was your current 2. Now it's gone. You are equals to current 2 dot next. Current 2 dot next is this one, 7. Now you're holding 4 is pointing at 7. So current to dot next. So your current to is now at 7. Your current to is at 7. So again, you're checking, is your current to, again, we are still in the orange loop. Current to dot next is not equals to null. So current to is 7, dot next is not null. It's pointing at 8. So yes, our current to dot next is not null. We are going inside if current to dot next dot data. So current to is this one. Let me is 7 dot next dot next is pointing at 8, dot data will be 8. So current to dot next dot data, which is 8, equals to current dot data is 5. Is 8 equals to 5? No, our if condition is not true. Go in else, and in your else it says current to, move the current to the next node equals to current to dot next. Current to is now moved to current to dot next, which is 8. So our current to is moved here. So our current to is pointing at 8. Now you check the orange loop. Again, we are still in the orange loop. You will run orange loop as long as your current to is not null. While current to dot next is not equals to null. Is current to dot next, this is null. I forgot to put it now. Like this. Is current to dot next is null? Yes, this is true. So it means exit this while loop of inner orange loop where you have and do current equals to current dot next. Now the purple game current equals to current dot next is this one. So now this current is moved to the next one. So your current is pointing at dot next, which is the next one, which is 4. Let me put it below. It's pointing at 4. Now again, what you do, current is equals to current dot next. Your current is now pointing at 4. You check the while loop. Is current is not equals to null? No, current is not null. Is current dot next is not equals to null? No, current dot next is pointing at 7. Is it null? No, it's not null. It's holding 7. Then go inside, and what you have, current to is equals to current. So your current to started from here. Now your current to is set back to, your current to was here. You have cross it. Your current to is now equals to current. So your current is 4. So your current to will be pointing at here. Whatever the current is pointing at. So both are pointing at 4 right now. Now you're checking inside of this orange loop again. So this current to will start again the same way, comparing 4 with 7 and 8. So current to dot next is not equals to null. This is your current to dot next is not null. It's 7, and you're doing current to dot next dot data. Current to dot next dot data is 7. Is 7 equals to, now which data you're comparing? Current dot data. Your current is 4. Is it equals to 4? No, it's not equals to 4. Current to equals to current to dot next. Move your current to your next one, which is this one. This is your current to your 7. You check while current to dot next is not null. Dot next is not null. We have 8. So we go inside. You have orange loop again. If current to dot next dot data, current to is 7. Dot next dot data will be 8. Is 8 equals to current dot data? Current dot data is 4. Is 8 equals to 4? No. Current 2 is equals to current 2 dot next. Move your current 2 to the next one. Current 2, and this one is gone. So current 2 is pointing at 8 now, and you check orange loop, this still running. Current 2 dot next is not equals to null, which is false. Current 2 dot next is now null. Stop this orange loop and increment your current, which is current equals to current dot next. Current is pointing at 4. Current dot next is pointing at 7. So your current is now moved to the next one. Your current is pointing at 7. Any questions? Is everything making sense? Are you guys on track? Current is now pointing at 7. Okay, Now, while loop again, is current is not equals to null? No, current is not null. Is current dot next is not null? No, it's not null. So you go inside and your current two is updated. So your current two is, your current two is set back to whatever the current is. So your current is 7, your current two is also 7. So your current two is also pointing at 7. Now you have inner loop where current two dot next is not null. It's not null. So we go inside. If current two dot next dot data, which is current two dot next dot data, current two is this dot next dot data 8 equals to current dot data is 7. Is that true? No, they are not equal. Else you said current two equals to current two dot next. Increment your current two to the next one, which is current two is over here dot next. You check, is current two dot next is not equals to null? It is null. Stop the loop. Current is equals to current dot next. Your current is incremented to move to the current dot next. This is your current. And now you check your outer while loop with purple one. Current is not equals to null. Current is null. So we will not check the rest of the, because there is nothing to compare next. All the duplicates are removed and your final list. So this loop becomes false and end. And this is your final list. You have only removed this duplicate, which is 5, and rest of them are no duplicates. So your list is, so you will return your front, or if you want to print, you will print your front. And when you print your front is 5, 4, 7, and 8. This is your final list. Hope this makes sense. Any questions so far?